Greetings, detectives. This is Mrs. McKay, ready to work on our fourth clue for case 2. So learning target clue 2-4. And that learning target is I can solve a system of equations. So go ahead and write the word equations. By substitution. And that's what this entire lesson is going to be about. How to solve a system of equations using something other than graphing, using a method called substitution. Now, let's just do a quick review. First of all, let's remember what a system of equations is. Remember, a system of equations is two equations, which are lines, linear equations. Those equations can be graphed as lines. And sometimes, and we're looking at the relationship between those lines. So for many systems of equations, the two lines actually intersect. They actually intersect. They have one point that's a common point. And we'll just say that right there is where they intersect. And that common point has an x and a y. And the x and the y, if I put them into either equation, will make a true statement. Okay, so there's only one solution when we have a system of equations where the two lines intersect. Another way that our system of equations can be related to each other is they can be parallel lines. We graph one line, we graph the other line, and the two lines never intersect. So in that situation, we have no solutions. There are absolutely no solutions, and we say that the solution is the null set, meaning it doesn't exist. Okay? Because never, ever will those two lines cross, and that means they'll never have a point in common, so there'll never be an x and a y that can be a true, make the equation a true statement for both lines at the same time. And then, of course, our last way that our system of equations can be related is they can be the exact same line, meaning that every single line, every single point on the line is exactly the same as every single point on the other line because it's the same line. And when that occurs, we say that there are infinite solutions. And so that's why I drew the sign for infinity, which is a sideways 8. Infinite solutions means it goes on and on. There are so many solutions we can't count them. It goes on and on because the lines go on and on. All right? So that's just a quick review of systems of equations. And now let's talk a little bit about substitution. Now you've heard the word substitution in other situations, maybe even in math. You understand what it means to have a substitute, whether it's in a sports game when somebody substitutes in for another person, or even in school when you have a substitute teacher who comes and takes the place of your teacher. So a substitute comes in and takes the place. And that's what happens in math as well. And you've actually already done some substitution. You've done things where you've been given something like a plus b minus 3, and you've been told to evaluate that. If a equals 1 and b equals 4, we'll say that. Okay, if a equals 1 and b equals 4, figure out what a plus b minus 3 is. And you've actually substituted 1 for a and 4 for b. And you've solved this problem. You figured it out. 1 plus 4 is 5, minus 3, and you've said it equals 2. So you have already used substitution. So we're just going to take a little bit further, and instead of substituting a value like a, or 1 for a, we're actually going to substitute something like x plus 3 or 2y minus 4 in place of another variable. So we're taking an expression and we're going to replace a variable with that. We're going to substitute it. So there are times when substitution works really, really well and times when it doesn't. Just like there are times when graphing works pretty well and other times when graphing is a pain. And in my opinion, graphing is almost always a pain because you have to be so careful when you graph two lines, you have to make sure that you're graphing it accurately, you're drawing your lines perfectly, and then you're looking for where those two lines cross. And that's just a little tricky, especially if they don't cross right on an exact integer point, right? If it's some fraction, then it gets really crazy. So graphing doesn't work always that well, and it's just a lot of extra work. So here's another way, substitution. But substitution works best when you can easily isolate, when one variable, so go ahead and write this down, when one variable in at least one equation, at least one of the equations has one variable. When one variable in at least one equation can be easily isolated. That means we can get it to a place where we can have that variable equal to everything else. So we can move everything over and say that that variable, whether it's an x or a y, is equal to everything else. All right? So substitution works best when one variable in at least one equation can be easily isolated. Now, let's go ahead and do some of these problems. Look over on the left-hand side where it says steps to solving systems by substitution. Now, this has lots of words and it's hard to explain. It's better just to see it, but I want you to be able to have these steps so that you can review them. The first thing you have to do is you have to decide which variable you want to isolate, and then you have to isolate that variable. And so you always have two variables. When you're dealing with a system of equations, you always have two variables, and since we're talking about linear equations and we're talking about y equals mx plus b, it's almost always that those two variables are going to be an x and a y. Sometimes you might give them other letters, like if you're doing a word problem and you're figuring out two things, but in this situation, just to learn the substitution, we'll say x and y are our two variables. But you always have to decide which variable you want to isolate first. So, and which equation you want to isolate it in. And so we're going to call that first variable just the a. We'll say variable a, that's our first variable, and our second variable will be variable b. It's our second variable. All right? So let's look at this first set of equations. We've got x equals 4y, 4x minus y equals 75. And one of those equations has a variable that can easily be isolated. Which one do you think it is? Well, did you decide that it should be this first equation and this x right there? Do you see that x? It's already isolated. It's all by itself. We don't have to do any work. We already know that x equals 4y. In the second equation, 4x minus y equals 75, x isn't by itself. It's still got a 4 in front of it. It's got a y on one side. It's not isolated at all. But this first equation, x equals 4y, clean, nice and easy. X equals 4y. It's already been isolated. So let's move on. So we're going to go ahead and say that this is our variable a. X is our first variable. And that means b must be our second variable, or y must be our second variable, and we'll call that variable b. And what we're going to do according to step 2 is we're going to substitute what is equal to that isolated variable, which happens to be x in this situation. We're going to put it in place, whatever it's equal to, which is the 4y. We're going to put it in place of that variable in the second equation. So what's variable a? Well, it's the x. So whatever x is equal to, we're going to substitute it for x in the other equation. So this was our first equation. This is our second equation. All right? So we're going to take what x is equal to in the first equation, because that's where the x is isolated, and we're going to replace it. We're going to replace x with what it's equal to in the second equation. So that just means I have to rewrite my equation. I'm going to use a little bit different color. I'm going to rewrite it. I'm going to say 4 times x. Now that's the one we're replacing because we know x equals 4y. So I'm going to, in place of x, I'm going to say 4y. 4 times 4y, and then I have to finish writing my equation, minus y equals 75. Now, I want to quickly just write something over here because I want us to remember what we're actually doing. We are trying to find the value of x and the value of y for each of these equations where x and y are the same thing. Okay? So where x in this first equation is the same x in the second equation, because we're looking for that single point where the two equations cross, where they have a common x and y. All right? So that's what we're doing, is we're trying to find what x and y are. So what we've done so far is we've isolated the x, and now we're going to take what x is equal to, happens to be 4y, and we're going to replace the x in the other equation with that 4y. And that's what we've done here. 4 times 4y minus y equals 75. And now all we have to do is solve for y, because we only have y's. So let's figure out what y is. 4 times 4y is 16y minus y equals 75. 16y minus y, all I have to do is combine like terms and I get 15y. Notice I didn't have to do any moving across an equal sign because it was all on one side. 15y equals 75. Now I have to isolate my y, so I'm going to divide both by 15. And I get y equals 75 divided by 15 is 5. So y equals 5. So I've just figured out what y is, so I can write it up here. Y equals 5. Okay? I'm not done yet because I need to find out what the x is. So how am I going to figure out what x is? Well, according to my steps, I've already done this third step, solve for the remaining variable. So my remaining variable was y, and I solved for it. That's what was left behind. That's our b. Y was our b, our second variable. So now we're moving on to step 4. Once you know what the value of the second variable was, which happened to be my y, it's 5, then I can substitute the value in one of the original equations and solve for that first variable, which happens to be x. Okay? So I'm going to take my 5 and I'm going to choose one of my variables. I've got x equals 4y, and I've got 4x minus y equals 75. And I'm going to pick the easiest one, which in my opinion is x equals 4y. And I'm going to rewrite this equation, but instead of writing 4y, I'm going to write 4 times what y is equal to, which is 5. So 4 times 5 is 20, so x equals 20. X equals 20. Now, x equals 20. So now I have my x and my y, which means that 25, which is the point 25, is where these two lines, x equals 4y and 4x minus y equals 75, it's where these two lines intersect. It also means that if I put 20 in for x and 5 in for y in either equation, I will come up with a true statement. So let's try it. We've already done this first one. We've said x is 20 equals 4 times y, which happens to be 5. So 4 times 5 is 20. 20 equals 20. That works. What about this second one? Can we do this second one? 4 times x, which is equal to 20, minus y, which is 5, should equal 75. Does it? 4 times 20 is 80. 80 minus 5 Does that equal 75? It sure does. 80 minus 5 equals 75. 75 equals 75. True statement. So I've just solved the system of equations with no graphing at all, just using algebra. Pretty tricky and nice, isn't it? All right, let's do another one. We're going to follow the same steps. We're going to follow the same patterns. We're just using two new equations. So this time I have an equation that says 4x plus y equals 12. And I have a second equation that says negative 2x minus 3y equals 14. So the first thing I want to do is I want to find an equation. One of these equations hopefully will have a variable that will be easy to isolate. In our first one, the variable was already isolated. The x was already isolated, so that was easy. That wasn't a problem at all. That was a pretty simple thing. This one doesn't have a variable sitting all by itself completely. The 4x and the 2x, both of them are not alone by themselves. In the second variables, y and negative 3y, they also are not completely by themselves, but I think y is a little bit easier to isolate, and I think in this first equation, y is my better choice to isolate, because really all I have to do is get the y by itself, and there's not too much that's needed to do that. So I'm going to go ahead and isolate this y by subtracting 4x from both sides. And I'm going to rewrite it as y equals negative 4x plus 12. Now I want you to notice that I did not try to subtract the 4 from 12. Even though I wrote it underneath it, I was just running out of space. It's really 4x is its own separate term. It's like dogs, and 12 is its other separate term, like cats, and I cannot subtract dogs from cats or cats from dogs. They're not the same, because 4x has an x, 12 does not. Okay, so I can only combine like terms. So negative 4x plus 12, two separate terms. I also put my x in front, and if you wrote 12 minus 4x, that's okay, but I just like to always have my variables first, my constants last, and that's just a good standard way of doing things, and it's a good habit to get into. All right, so I have y equals negative 4x plus 12. And now I need to do some substitution. And that means I'm going to take whatever my first variable was, which I decided that I was going to isolate y, so that's my a, it's my first variable. And I'm going to substitute it for my a, or that same variable, in my second equation. So I'm going to take what y is, which happens to be y is equal to 4x plus 12. I'm going to take that whole thing, negative 4x plus 12. I'm going to take that whole thing and I'm going to put it in place of y, because y is equal to that. I'm going to put it in place of y right there, in that 3, right there where the y is in the second equation. And I'm going to rewrite that. So I'm going to write negative 2x minus 3 times y. And what's y equal to? It's equal to negative 4x plus 12. So I'm going to write negative 4x plus 12 equals 14. So I've rewritten this equation, negative 2x minus 3y equals 14, and I've replaced the y with what y happens to be equal to, negative 4x plus 12, right here. Okay? Now I just have to solve it. So why don't you go ahead and solve it and see what you come up with. See what you come up with. What is x equal to? Now, the first thing you should have done when you solve this, you got your negative 2x, is you have negative 3, and you have to multiply it times the negative 4x, and then you also have to multiply the negative 3. Got to multiply that negative 3. Don't ignore that minus sign. It's a negative 3 times the 12. So negative 3 times negative 4x is a positive 12x. And negative 3 times a positive 12 happens to be a negative 36. And that's equal to 14. You should have combined your two like terms. Negative 2x plus 12x makes a positive 10x. And then you have minus 36 equals 14. You can add 36 to both sides because we're solving for x. And you should have 10x equals 14 plus 36 is 50. Divide both sides by 10, and you get x equals 5. Now, I have not done what I wanted to do, which is just to remind myself what I'm doing. I'm solving for x and y. So the x is 5. So I'm going to put 5 right there. All right, x is 5. I just solved for x, and I figured out that it's 5. But I'm not done yet because I have to, once I know the value of my first equation, my first variable, which happens to be x. Actually, it wasn't my first variable, it was my second variable because after I've chosen one variable, then I have to actually solve for that second variable, which happens to be the x, and then I'm going to go back and I need to solve for my first variable, which was the y. So I'm looking at my two equations. I can pick either one. It should work in either one. And I'm going to take x, which happens to be 5, and I'm going to replace the x with that 5 and solve for it. And I think I'm going to choose this first equation just because the y is already by itself. There's not as much work for me to do. So I'm going to rewrite this equation. This time, I'm going to write it as 4 times x, which happens to be 5, plus y equals 12. And I'm solving for y this time. 4 times 5 is 20, plus y equals 12. Subtract 20 from both sides, and I get y equals negative 8. Y equals negative 8. So now I've just figured out the point. It's 5, negative 8, and that means that the x value and the y value, the 5 and the negative 8, can be plugged into either one of these equations, and it should be a true statement. It's where these two lines intersect. It's the point, the one place that these two lines have in common. And I can check that by plugging 5 in for x and negative 8 in for y in both equations. Well, I've already done this first one, but we'll just do it really quickly in our heads. 4 times 5 is 20, plus y, which happens to be a negative 8. 20 plus negative 8 equals positive 12. Works. Let's do this second one and see if it works on this one. Negative 2 times 5 minus 3 times negative 8 equals 14. All right, negative 2 times 5 is a negative 10. Negative 3 times a negative 8 is a positive 24. It should equal 14. Let's see if it does. Negative 10 plus 24 is positive 14. 14 equals 14. So there you go. We've got a solution. So it worked in both of them. So the solution to this system of equations is 5, negative 8. Let's do another one. Let's look at this one. Y equals 2x minus 1 and y equals 3x plus 4. Take a minute and you decide what is the variable that we should isolate, because that's always our first step, is what variable should we isolate? Now, what I'm doing is I'm writing over here x and y, because that's what I'm solving. I'm trying to figure out what the x is and what the y is, and I'm trying to figure it out. So I think you probably decided that the y needs to be isolated. But I want you to notice something. I want you to notice that both of them have already been isolated. The y's been isolated in both situations. So I'm going to take this y, which happens to be 2x minus 1, and I'm going to put it in place of this y over here. So if this y is 2x minus 1, then that means 2x minus 1 can go in the place of this y here, and there's really nothing else I have to do except write the problem. 2x minus 1 equals, so 2x minus 1 is y, equals the other one, which is 3x plus 4. And now all I have to do is solve it. So why don't you go ahead and solve it and see what you come up with. Here's how I did it. Add 1 to both sides. And I got 2x equals 3x plus 5. Subtract 3x from both sides. And I got negative x equals 5. Problem is, I cannot have a negative x because I need it to be a positive x because that's what I'm solving for. I'm solving for x, not the opposite of x. So that means I need to get rid of that negative. So I'm going to multiply both sides by negative 1. And I get positive x equals negative 5. Is that what you got? X equals negative 5. Now that I know what x is, I can go back and figure out what y is. And that means I can just pick one of these two equations. I'm going to pick this first one just because it looks easier. Y equals 2x minus 1. And I'm going to write it right here. Y equals 2 times x, which I now know is negative 5, minus 1. So that means y equals 2 times negative 5 is negative 10, minus 1. So y must equal negative 11. Now, if I did it right, it means that it's going to be true for both equations. Negative 5, negative 11 will be true for both equations. So we already did this first one. Y is negative 11. 2 times x, which is negative 5. So 2 times negative 5 is negative 10 minus 1, negative 11. Y is negative 11, and negative 11 equals negative 11. Let's do this other one. Y is negative 11, and it's equal to 3 times x, which is negative 5, plus 4. So negative 11 must be equal to 3 times negative 5 is negative 15, plus 4. So negative 11 equals negative 11. Voila! We did it. All right, so we've just solved 3 different equations using substitution. And notice all we did was we isolated one variable, figured out what it was, stuck it in to the other equation, solved for the opposite, that second variable. Once we figured out what the second variable was, we went back to figure out what that first variable was, and then we just checked ourselves. Now, let's do these last 2. These last 2 are a little tricky. And actually, I think I'm going to have you, first of all, in this first one, tell me which variable I should isolate. I think you can see it pretty easily, but just in case you don't, let's go ahead. We'll go ahead and guess first. All right, so I hope that you decided that you needed to isolate the x because it's already isolated, right? So all you need to do is take negative 3y plus 7 and put it in place of the x, right there. So take negative 3y plus 7 and put it in place of that x. So I'm going to write 2 times x, which is negative 3y plus 7, okay? Now I'm rewriting this equation down here. 2 times negative 3y plus 7, that's my x. Now I got to finish writing my equation. Plus 6y equals 14. All right, now all I got to do is solve it. Why don't you go ahead and solve it and see what you come up with? Let's see what you did. 2 times negative 3y gives us negative 6y. 2 times 7 gives us 14. So now I have negative 6y plus 14 plus 6y equals 14. I'm going to go ahead and combine some like terms, and I get negative 6y plus 6y gives me 0 plus 14 equals 14. So I ended up with 14 equals 14, which that's true, but I'm supposed to be solving for x and y, aren't I? Remember, that's what I'm supposed to be doing. I'm supposed to be figuring out what the x and what the y are. And I just lost my variables. I don't know what either is because I don't have any variables left. They canceled out. So when you end up, I'm going to put a big red star here. When you end up without a variable, when you're using substitution and you've replaced, one variable with another expression, and then you solve it and you lose your variables disappear, you have two options. One is it could end up being a true statement like 14 equals 14 or 3 equals 3. When that happens, that means that your two lines are the same line. It means they're the same line, and that means then that you have an infinite number of solutions, right? Infinite number of solutions because your two equations are the same line. If you had taken the time to graph them, you would have seen that they were the same line. So when you lose your variable and what you're left with is a true statement like 3 equals 3 or 14 equals 14, then you know that you have infinite number of solutions because it's the same line. Let's do this other one over here and see what happens. So it doesn't matter what x and y are, whatever x is and whatever y is, there's going to be a bunch of these that are true on this line. A bunch of points, okay? There's many, many, many because it's the same line. It's every single point on each line is the same point on the other line. So let's look at this next one. Again, remember, we are looking for the x and the y. Okay, and let's go ahead and identify the variable that we want to isolate, and I think it should be this one right here, the y, right? Which means we're going to take whatever this y is equal to, and we're going to substitute it. So here's what this y is equal to, and we're going to substitute it for that y right there, okay? So I'm going to rewrite this problem, this top problem. I'm going to rewrite it, and wherever I see a y, I'm going to put 3x plus 2 in its place. So I write 6x minus 2 times, what's y equal to? Well, it's equal to 3x plus 2. 3x plus 2. And the whole thing equals negative 4. And I'm going to solve. Why don't you go ahead and solve too and see what you come up with. Here's what you should have done first. I always like to take care of my distributive property, so I've got negative 2 times 3 and negative 2 times 2. Remember that negative has to follow the 2. So I ended up with 6x minus 6x minus 4 equals negative 4. Did I do that right? So now, actually, this wasn't solving the way I wanted it to. When I do 6x minus 6x, I get 0 minus 4 equals -4, which is a true statement. -4 equals, well, actually, zero minus 4, yep, is -4, equals -4. So it's, again, a true statement. So I didn't actually give you a problem that comes up with a false statement, which is kind of a bummer because I thought that I had. Sometimes when you solve an equation, you're going to end up with a false statement. You're going to end up with something like this: 0 equals 8. I could quickly write one, but I think I will let you just see it as you're doing practice problems. It's always going to be when you have two parallel lines. You're going to end up with no variable, and that no variable is going to have this craziness at the end where it says 0 equals 8 or 3 equals 4. It's not going to be a true statement. It's going to be a false statement. And when that happens, it is the null set because you have parallel lines. Okay? Parallel lines. And that means there are no solutions. There are no solutions. So if you are solving using substitution and your variables disappear, meaning they get subtracted from each other, and you end up with a true statement at the end like 3 equals 3, you know you're dealing with the same line and you have infinite number of solutions. If your variables disappear, but you come up with this crazy answer like 0 equals 8 or 2 equals -3, then you know there's no solution and it's parallel lines. Now it's time for you to create a key idea. So look through these notes. Think about what are the key ideas that will help you to remember how to solve using substitution. Write that down. It's going to be different for each person. It's going to be what matters to you, what's going to help you remember. Write those key ideas here and do the practice. Do that. I think it's a Slack math worksheet. You'll get an opportunity to solve different types of systems of equations. Some will have a solution. Some will have infinite number of solutions. Some will be parallel lines. Practice them, get comfortable with it, and I'll see you in class.